Hello and welcome back to video number 10. Today we are going to code ArrayList. An ArrayList is a data structure which is based on array, of course. But in this ArrayList, you can use it to add as many items as you want. ArrayList is one of the most widely used data structure in Java. So if you are going to work in any project, you will see that most of the people make use of ArrayList because it is efficient and it is provide you all the benefits of an array. You can think of ArrayList as dynamic array. So as you already know that array is bounded, you define a given number of size and you can only store that much item. ArrayList gives you an ability to grow your array, and you can grow your array as soon as you hit the limit of that particular array. Let's say you have 10 items in your array and you insert the 11th item. In the normal array, you cannot do that. You will get the exception array index out of bound. Since your array is bounded and your size of the array is 10, you cannot add the 11th item. When we implement the array list, your array can grow dynamically. If you have defined an array that can store 10 elements, but now you want to insert the 11th one, you can do that. So ArrayList will basically create a new array of bigger size and copy your smaller array items to that array and then insert the 11th item. This is how you can insert as many items as you want in an ArrayList. ArrayList, you get all the benefits of an array, get random access. So if you want to access any element in the ArrayList, it takes constant time. You don't have to iterate over the array like we did in LinkedList. Instead, you can just go there in that index and get that item. So read time is constant. And that takes some time. Insertion in ArrayList can take a bit more time as compared to linked list, because if you have hit the limit of the array, then you will have to copy all your smaller array into a bigger array, and that will take some time. But in a longer run, with amortization, it comes to a constant time. So ArrayList is one of the most widely used data structure in every project. So let's head back to our IDE and implement it. See you there. This is where we left off. We implemented wLinkedList. So I'll close these tabs and I'll create a new package called ArrayList. And inside this package, I'll have my class, my ArrayList. Make it generic. Here comes our first test case. So in this, we have to add a new item to the array. So I'll write test case for that. So we'll assert on the size of the array. Now here we have to maintain two different sizes. So first one, the array's length, and the array size. So array size will hold the number of items it currently has, and length will be the size of the given array which we are working with. So for that, I need to first create an array. Here I can give a default size, and in this case, let's keep a default size to 2. Now I'll insert the first element to the array. So we'll tackle this problem step by step, and that's why test cases will come in really handy. So if I get this item, I'll just take the array, take the size, and I'll just insert this element to that index and increment the size by 1. Actually, I can increment the size here itself. I'm going to create this variable. Starts with 0. I'll create one more method for size. Let's run this test case and see if it's working. We will get array index out of bound, and then we will try to resolve that exception. So index 2 out of bounds expected because it won't insert the third element. So here we have reached the end of the size after inserting these two elements. That's why for the third element it gives us the error that array index out of bound. Cool. So now we have to resolve this exception. So for that, we'll insert one condition. If size plus 1 is greater than array.length, it means that we have to grow our array here. How can we grow the array? To grow the array, we have to create a new array. Here we have to give the size of the array. So what we can do is, well, this is not a hard rule that we have to do it this way. I think in Java implementation, we find a sweet number like 1.8 something, and we multiply the length of the array with that number and then grow the size by that. But to keep it very simple, we'll just make the array of twice the length of the given array. So in this case, the default length is 2 because we are doing this for the first time. So when we multiply by 2, it will be 4, then 8, then 16, then 32, and likewise it will keep on growing. Now we have a new array. This new array is empty, obviously. So we have to copy everything that we have in our existing array to this new array and assign our pointer to this memory address instead of the previous one. We can either make use of existing method that Java provides us, or we can use a loop to copy everything from array 1 to array 2. Let's try to use it, the Java function that we have. We have copy of. We want to make a copy of our existing array, okay, the length of the array. So the length of the array is, this is going to be our new array. So we don't even need that line. It will do it for us. So what we are saying here is we want to copy our existing array into a new array of length twice of this size. And then we'll do the usual. We will go and insert that item here and increment the size. Let's see if it is working fine or not. Now we shouldn't get null pointer exception and everything should work fine, as you can see here. Great, so far so good. Now what we want to do, we want to get the element by index. So let's write a test case for that. And reading is really easy if we have the index in our array list because of the random access of array. We can just go to that index and get whatever value we have. So I'll just go to this index and I'll get the value. I'll typecast it to the given type and then return it. And this should work. Awesome. So far, everything's working fine and it is easy to understand as well. Now, what do we need to do? We have append functionality, we have get functionality. Now we need to remove the item by index. I'll remove 102, which is on index number 2, and then I'll assert on the size. Now the size should be 4. And also we can iterate over the array and see if now we have the array in the right order. Now I'll read every index and see if it is correct. So assert equals. Let's remove the element from the array by index. So in this, we will start from the index and we will just left shift the items from that point. We want to remove the item which is in the index. So we'll start one after and left shift it. And this should do it. And we also have to decrement the size. Oh, it should be array item, not the index. I make silly mistakes all the time, and test cases saves me. It makes me aware of my mistakes very early. Great, so far we have implemented add functionality, read functionality, remove functionality. Now we need to remove by item. Now I will remove the item by value. So in this, we'll have to search the entire array for that value. And then once we find that value, we can simply remove it. But this will clash with the existing method that we have. So I'll say remove. So I'll make this method remove by index. And this one remove. I'll keep it same because everything's going to be same. Instead of 104, I can make it 102 and everything will be same. Now let's implement this real quick. Now it's just a matter of searching the entire array for that given value, that given item. And once we find that, we have to do the right shift. That's all we have to do here. So I'm making use of the existing method that we have here already. So here I'm saying that if we find the element in the array, we just remove it, but we cannot decrement the size here. I'll try once again and this should work. Awesome. Let's run all the test cases to see if it is working fine, and if it does, we are done with ArrayList. I hope you enjoyed this video, and in the next video we'll start with or we'll create a small project to compare all these algorithms and see which one is the fastest and most suited for which kind of operation. I think that would be fun. And in the next video we'll start with graph. That's going to be fun. Graphs and trees. So yeah, see you there. See you in the next video. I hope you're enjoying it so far, and do give me feedback in the comment below. Now, I need that. Thank you very much. See you. Bye bye.